Chapter 1.9 is the distance formula, midpoint formula, and we'll be getting into circles as well. So starting with the distance formula. So this formula is going to tell us the distance between 2 points in the rectangular coordinate system. We'll call them x1, y1, and x2, y2. And this actually comes from the Pythagorean theorem. So just for a reminder of what the Pythagorean theorem tells us, it says that if we have a right triangle, so a right triangle being a triangle that has a 90-degree angle in it, and we have the sides A, B, and C, where C is the hypotenuse, the side opposite the right angle, then the Pythagorean theorem says that A squared plus B squared equals C squared. So one of the sides squared plus the other side squared equals the hypotenuse squared. So let's use that idea here and take a look at 2 points on the rectangular coordinate system. So we have x1, y1, and then we have x2, y2. So they can be anywhere in the rectangular coordinate system. I just kind of plopped them right there. And let's say we want to find this distance d between them. So we want to find that straight line. We want to find the length of that line that connects them. So we're going to do this actually using the Pythagorean theorem. We can create a right triangle and have it look like this, where this would be the right angle. And the distances between, for that vertical line that we drew, it is the difference in their y coordinates. So this would be y2 minus y1. The horizontal distance would be the difference in their x coordinates, so x2 minus x1. So based on the Pythagorean theorem, we know that the x2 minus x1 squared plus the y2 minus y1 squared equals the hypotenuse, which is the distance we're looking for, squared. Okay, so that's just a squared plus b squared equals c squared. And we could solve that by by taking the square root of each side, or sorry, by taking the square root of each side here. So it's going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. And the square root of d squared is just going to equal d. So that actually gives us the distance formula. It's just the hypotenuse solved for in a right triangle that we created between 2 coordinates. So here it is more formally written. The distance between 2 points, x1, y1, and x2, y2, is the square root of x2 minus x1 squared plus y2 minus y1 squared. So let's do a couple examples here. So we want to find the distance between -1, 4 and 3, -2. So before we do that, let's just plot them down here to get an idea. So -1, 4 would be right here. And was it 3, -2 would be right here. So we're trying to find that distance between them, which would be this line, which would be our distance d. Okay, so we're trying to find the length of that line. So let's use that distance formula. So it's going to be d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And the coordinates here, we can call the first coordinate x1, y1, and we can call the second one x2, y2. So all we have to do is plug these in and simplify it. So it's going to be x2 minus x1 squared, so that's going to be 3 minus -1 squared, plus y2 minus y1, so plus -2 minus 4 squared. And simplifying this, we're going to get, that's going to be 3 minus -1 is 4, so 4 squared plus -6 squared That gives us 16 plus 36. And that gives us square root of 52. So we can actually simplify this a little bit. We can think of two numbers that multiply to 52 where one of them is a perfect square. That would be 4 times 13. 4 is a perfect square, so the square root of 4 is 2. And the square root of 13 we just leave as is. So I'm just going to write this as d equals 2 radical 13. Okay, so let's do another one. So find the distance between 5, -1 and 0, -4. So let's graph these just to get an idea of what we're looking at. 5, -1 is right here. And 0, -4 is right here. So we're trying to find that distance between them. So the length of that red line. So using the distance formula, we'll say the first xy coordinate is x1, y1, and the second one is x2, y2. And we're going to plug it in. So square root, we have 0 minus 5 for the x coordinates squared, plus the difference in the y coordinates, -4 minus -1 squared. So we end up getting -5 squared. So if you have a negative number being squared in parentheses like that, make sure you keep that in parentheses because it's always going to end up giving you a positive number. And then the next one we have -3 squared. Should have had another set of parentheses up here above it. Okay, and then simplifying this we get 25 plus 9. And this is going to end up giving us the square root of 34. Okay, so whatever that is, that's almost 6, which it looks like it might be 6 would be about a reasonable approximation for the length of that red line. Okay, so for the next thing, it's the midpoint formula. So if we have two coordinates, once again, x1, y1, and x2, y2, and we draw a line between them connecting them, we can actually find the coordinate of that line segment's midpoint using this little formula right here. So the midpoint is going to be a coordinate. It's an xy coordinate between two coordinates. The x coordinate is x1 plus x2 divided by 2. So it's the x coordinates added up divided by 2. And the y coordinates, the new y coordinate for the midpoint is the y1 plus y2 divided by 2. And that's the y coordinates added up divided by 2. So all of this is essentially is just the average of the x coordinates for the new x coordinate and the average of the y coordinates for the new y coordinate. Okay, so let's do this example. Let's find the midpoint of the line segment connecting 1, -6 and -4, -4. So once again, let's plot it down here so we get an idea of what we're doing. So -4, -4 is right here in quadrant 3. 1, -6 is right here in quadrant 4. And we connect them. And it looks something like that. So the midpoint here looks like it's about right here. So we're going to find that midpoint. And we're going to find it using this formula up here. So it's going to be the midpoint equals that formula from before, and our first coordinate given is going to be x1, y1. The second one will be x2, y2. And we're going to plug those in. So it's going to be the sum of the y coordinates, so 1 plus -4 divided by 2. And then the sum of the y coordinates, -6 plus -4 divided by 2. And if we evaluate this, we end up getting -3 over 2, and then we get -10 over 2, which is -5. So that's going to be our midpoint, which I'll just call M. So that's our midpoint. Let's go back and make sure that it makes sense. negative 3 halves comma negative 5. So that actually does look like exactly where our midpoint is. It's negative 3 halves in the x direction and negative 5 in the y direction. Let's do one more. So we want the midpoint between 0 comma 6 and negative 10 comma 9. So 0 comma 6 is going to be right up here. And then negative 10 comma 9 is all the way over here. So we want the midpoint connecting them on this line segment. So it looks like it might be about right here, so we'll call that M. So we're looking to see what that is. So plugging these in the formula, we're going to get 0 plus negative 10 for the x coordinates, then divided by 2. And then for the y coordinates, 6 plus 9 divided by 2. Call that M again, just for midpoint. So it's going to be negative 10 divided by 2, which is negative 5 for the x coordinate. 6 plus 9 is 15, 15 over 2. So that'll be about 7.5, but we'll leave it just like that. So taking a look to make sure it makes sense with our answer, that midpoint, that M, actually does look like it is exactly at negative 5 comma 15 over 2. So the next thing is the circle. So moving on to circle. So first, starting with the definition of a circle, I'm sure we all know what a circle is, but there is a technical definition. So a circle is going to be the set of all points in a plane that are equidistant from a fixed point. The fixed point is called the center. So the distance away from the circle's center to any point on the circle is called the radius of the circle. So there's going to be two different forms of a circle that we're going to see the equation in. So the first one is going to be the standard form of a circle. So the standard form of a circle, this one is actually very nice when it's in standard form because it tells us what the center is and tells us what the radius is. So it's going to be x minus h squared plus y minus k squared equals r squared, where the center of the circle is the h comma k. So it's the opposite positive or negative sign that we would see in the parentheses, and the radius is r. Okay, so then we have the just the diagram of a circle. Once again, we all know what it looks like, but we have the center h comma k in that circle, and then that radius r, leading to any point x comma y on the outside of that circle. So let's see an example here. So let's write the standard form of the equation of a circle with center negative 2 comma 3 and radius 4. And then we'll graph it. So we need the standard form. So standard form is going to be x minus h squared plus y minus k squared equals r squared. So we need h and k, and we need the radius r value. So we're given the radius is 4, and we're also given h comma k is negative 2 comma 3. So we actually just have to plug that in. So it's going to be x minus negative 2, so plug that in for h. Now plug in k, that's y minus 3 squared equals r squared, which is 4 squared. And then we want to simplify this a little bit. So it's going to be x plus 2 squared plus y minus 3 squared equals 16. So that's going to be the standard form of the equation of a circle. So let's graph it. So we have the center at negative 2 comma 3. So that's going to be right here. So the center is technically not part of the circle. It's just the point that we use to help us graph it. So the way that I like to graph these, radius of 4, you go to the center of the circle, and then we can go up 4 from that center, 1, 2, 3, 4. Put a dot, we go to the left 4, 1, 2, 3, 4, put a dot, down 4, and to the right 4. And then we connect those outside dots that look like a diamond, but obviously not a diamond. We connect it so it's a circle. So make sure it has curvature in it, so that would be our graph of that circle. Okay, for the next one, write the standard form of a circle with center 0, 0 and radius 2. So the standard form for the equation of a circle, x minus h squared plus y minus k squared equals r squared. So the center of the circle here is going to be 0, 0. So that is our h comma k, and our radius is given to be 2. So we plug all of that in, so it's x minus 0 squared plus y minus 0 squared equals 2 squared. So obviously if we're subtracting or adding 0, we don't need to write that. So that just simplifies to x squared plus y squared equals 4. Okay, and for the next one, write the equation of a circle in standard form, center 5, 7 and radius 5. So we have the standard form, and we have h comma k, which is 5, 7, the center of the circle, and then we have the radius is 5. So plugging these in, it's going to be x minus 5 squared plus y minus 7 squared equals 5 squared. And then just simplifying that 5 squared, we get x minus 5 all squared plus y minus 7 squared equals 25, and that is that one's equation. And then for the last one here, we want the standard form of the equation of a circle, center 0, negative 6 and radius 15. So our center of our circle, h comma k, 0, negative 6, radius of 15. We plug those in, x minus 0 squared plus y minus negative 6 squared. So I just have to be careful with the negative, equals 15 squared. So x minus 0 squared is just x squared. And then it's plus y plus 6 squared because of the two negatives that cancel to the positive. And then 15 squared is 225. Okay, so that's the standard form of the equation of a circle. So let's do another longer example here, going kind of in the other direction. So we're given the equation of a circle in standard form here. We have x minus 2 squared plus h, or plus y plus 4 squared equals 9. So this is in standard form. So it's in the form x minus h squared plus y minus k squared equals r squared. So the first question, we want to find the center and the radius of the circle. So the center of the circle is going to be h comma k. So the center, we just have to go to these two spots right here. But remember, it's the opposite signs of what you're looking at. So it's not negative 2, 4. It's positive 2, comma, negative 4 is our center of the circle. And then for the radius is going to be at the end, but that is, the 9 is not our radius. 9 equals r squared. So to find the radius here, it's going to be the square root of 9, which is 3. Okay, so I'll make a little note that that equals r squared. And now we want to graph it. So the center was 2, 4, radius of 3. So we go to the center, 2, negative 4, which is right here. And then it has a radius of 3, so I'm going to go 3 to the right, 3 down, 3 to the left, and 3 up, and then connect them. And it will look like that for our graph of the circle. So one more question here for this one. Let's identify the domain and range. So the domain is going to be the set of all x values here. So scanning it left to right, the domain is going to be from here to here. So that's going to be from -1 to 5. And it's going to be brackets because it's cutting through those points, so we include them. And then the range is going to be the set of all y values that exist. So scanning bottom to top, it's going to look like that. It's going to be those y values. So that's going to be from -7 to -1. Okay, so one more example from these ones. So we have x squared plus y squared equals 1 for the equation of a circle. So first one, we want to identify the center and the radius of the circle. So once again, this is in standard form. So nothing is written next to the x or to the y, nothing is being added or subtracted. So that means the center is going to be at the coordinate 0, 0. And the radius here is going to be the square root of 1, so it's just going to be 1. So r squared equals 1. So that means that r has to be the square root of 1. So technically, if we were solving the equation r squared equals 1, when we take the square root of both sides, we would get r equals plus or minus the square root of 1, which would be plus or minus 1. But since we're talking about an actual value of length, it can't be the negative version, and it just has to be the positive 1. Okay, so graphing this, 0, 0 at the center, radius of 1. So center here, radius of 1. So 1 to the right, 1 left, 1 up, 1 down, and we connect it. And it looks like that. So that little dinky circle in the middle. So this circle, this equation and this circle right here is actually something called the unit circle. And it's essentially the basic equation or the parent equation for a circle, just like we have the other basic or parent equations of functions. It's called the unit circle, like I mentioned, and it is very important in trigonometry, which we won't be doing for this class, but just keep that in the back of your mind. Okay, and then the last question for the domain and range. So the domain is going to be the set of all of the x values. So taking a look at that circle, the x values, it's going to go from here to here. So that means the domain is -1 to 1 for those x values, and we include them once again. And then the range is going to go from here to here, which is also -1 to 1 for the y values for the range. And they also get a bracket on the end. Okay, so for the next thing here, it's completing the square. So we're going to talk about general form of the equation of the circle in a second. But before we do that, I just want to mention what completing the square is. So what that does is it converts something in the form ax squared plus bx plus c equals 0 into the form a times x plus d squared plus e equals 0. So essentially it's converting a trinomial into a binomial squared. So for now we're going to be using the a value, so the coefficient on the x squared term. We're going to be assuming that that is 1 for simplicity. If it was not equal to 1, we'd have to divide everything by a so that it was equal to 1. So here are the steps for completing the square. So it's called completing the square because, like I mentioned, we're rewriting a trinomial as a binomial squared. So we have to add something to this to complete it so we can write it as something squared. So the steps here, which should make more sense once we do an example, it's not as confusing as it looks. So what we're going to do is add or subtract the constant to the right side. So it's going to be x squared plus bx equals -c. And the key for the next step here, that b value, which is the coefficient on the x term, we're going to add b over 2 squared to both sides of the equation. So that's just something you have to know to do for these. The result is actually going to let us complete the square. The result on the left side of the equation will be a perfect squared trinomial, which means we can write it as a binomial squared. So that means this, what it looked like in the beginning, will actually look like this then. So that whole entire right side, that looks pretty nasty over here, that whole thing is just a number, it's just a constant. Okay, so let's do an example here. So complete the square for x squared plus 6x minus 2. So step 1, we have to add the constant to the other side. So it's going to be x squared plus 6x equals 2. And the next step here is we have to add b over 2 squared to both sides. So let's figure out what that is. B over 2 squared, our b value is 6. So our b value is 6. It's the value on the x. It's the x coefficient. So that's 6 over 2 squared. And that gives us 3 squared, which is 9. So we're going to add 9 to both sides of the equation. So plus 9 plus 9. That's going to give us x squared plus 6x plus 9 equals 2 plus 9, which is 11. So what we have on this left-hand side right now, x squared plus 9x plus 9, this is now a perfect squared trinomial, meaning we can write it as a binomial squared. So what's good about this one is that we can actually just factor it normally. We think of two numbers that multiply to 9, that add to 6. That would be x plus 3 times x plus 3, just factoring a trinomial. We wouldn't write it like this though. We would write it as x plus 3 squared equals 11. So it should always happen like this for these types of problems because that's how we're setting it up. And what I'm going to do is I'm just going to write this as x plus 3 squared. I'm going to subtract 11 on both sides. It doesn't matter. So I'm going to write it as x plus 3 squared minus 11 equals 0. Once again, it doesn't matter. You could have left it as is. So we just completed the square for this. So another little hint for this is that we factored x squared plus 6x plus 9. That 3 value that came in here, right here, is that b over 2. So that is actually your b over 2 value that's right inside there, which it always will be. Okay, so let's do one more of these ones to make sure we're good with them. So x squared minus 10x plus 8 equals 0. So first step, let's get the constant on the other side. We have to subtract 8 on both sides. Okay, and the next step, we have to add b over 2 squared to both sides. So our b value is negative 10, so we have to be careful because it's negative 10. So negative 10 over 2 squared, that's going to be negative 5 squared, which is positive 25. So we're adding 25 to both sides. So we get x squared minus 10x plus 25 equals negative 8 plus 25 is 17. So now this left-hand side is a perfect square trinomial. And if we didn't know the shortcut, or if we didn't know, if we didn't know the shortcut for the b over 2 method that I mentioned a second ago, we would factor that. Two numbers that multiply to 25 that add to negative 10 are negative 5 and negative 5. So it ends up factoring as x minus 5 squared, because it would be x minus 5 times x minus 5 equals 17. And once again, I'm just going to write this as x minus 5 squared. I'm going to subtract 17 on both sides and get that right there. Okay, and then once again, it's important to note here that this negative 5 was just the b over 2 value from all the way up here. So that's always a shortcut that you can do for this method. Okay, so coming back to circles, because we're going to need that in a second. So it's the general form of the equation of a circle. So the general form for the equation of a circle is essentially just everything expanded out. So the general form is x squared plus y squared plus dx plus euy plus f equals 0. So d, e, and f are just real numbers. So everything is expanded out and it's set equal to 0. So we're going to convert from general form to standard form. So to do this, we're going to put the x's next to each other. So x squared plus dx plus the y squared plus ey. So we're just rewriting it, rearranging it, and then we get the constant, which is f, on the other side of the equation. And then we have to complete the square on both the x's and the y's separately. So we actually have to complete the square twice here. So the reason why we usually like this in standard form is because, like we were working with it before, how we were working with it, when it's in standard form, we can identify the center and the radius, and it's very easy to graph and know what that circle looks like. General form, not so much. Okay, so let's do some examples here. So we have x squared plus y squared plus 4x minus 6y minus 23 equals 0. So if we were just told to graph that, it would not be very easy to graph. So we're going to complete the square in order to graph it and put it in standard form. So rewriting this with the x's next to each other, x squared plus 4x, I'm going to put these in parentheses also, plus, so don't forget that plus because all we're doing is rearranging it, we're not changing anything, plus y squared minus 6y, and then we get the constant of on the other side, so we add 23 to both sides and we get that. Okay, so we did not change anything, all we did was rearrange the terms here. So now we have to complete the square on the x's, and we have to complete the square for the y's, just like we did. So we have to do two completing the squares. So for the x's, we have to add b over 2 squared to both sides. The b here is the 4, coefficient on the x term. So it's 4 over 2 squared, which is going to be 2 squared, which is 4. So we have to add 4, and then we also have to add it all the way over here. So we're going to do the same thing for the y's. I'm going to do it over here on this side. So we're going to add b over 2 squared to both sides. So the b here is negative 6. So it's negative 6 divided by 2 squared, which is negative 3 squared, which is positive 9. So now we're going to add 9 to both sides for the y. Okay, so I'm just going to rewrite this as x squared plus 4x plus 4. So that's the 4 that we added. It was with the x's. And then for the y's, it's y squared minus 6y plus 9 equals, we have to add up that whole right side, 23 plus 4 plus 9 gives us 36. Okay, so that was the hard part probably. So now we have to rewrite those trinomials both as binomials squared. X squared plus 4x plus 4, that just equals x plus 2 squared plus y squared minus 6y plus 9, that is y minus 3 squared, and that equals 36. So that is actually the equation in standard form for our circle. Once again, if you had to factor out both of these trinomials separately, the first one would be x plus 2 times x plus 2, but you rewrite it as x plus 2 squared. The second one would be y minus 3 times y minus 3. You rewrite it as y minus 3 squared. And if you wanted to do the shortcut, that value is your b over 2, and this value is also your b over 2. Okay, so let's graph this. So we need to identify the center and the radius. So it's in standard form, so the center is going to be negative 2 comma positive 3. So once again, we have to remember that it's the opposite positive or negative signs that we see. And then the radius is going to be the square root of 36, which is 6. So we're going to go over to the center, negative 2 comma 3, and then we're going to go 6 to the right, 6 up, 6 to the left, and 6 down. And then we're going to connect those with a smooth circular curve. And it should look something like that. So that circle is the graph of that equation. So if you've noticed, I haven't been calling circles functions at all, because circles are not functions, because they do not pass the vertical line test. But they are equations, and they can be graphed so that they're still equations. So the next one, we have x squared plus y squared plus 10x plus 12y equals 0. So let's get this in a form easier to work with. So let's get the x's next to each other. So x squared plus 10x, and then we get the y's next to each other, plus y squared plus 12y. There's no constant, so we don't have to worry about adding or subtracting anything, so it just equals 0. And now we need to complete the square on both of these separately. So doing it for the x's, it's going to be 10 divided by 2 squared, which is 5 squared, which is 25. So we're going to add 25 to both sides for the x's. And then for the y's, it's going to be b over 2 squared. The b for that one is going to be positive 12. So that's 12 over 2 squared, which is 6 squared, so 36. And then we're going to add that to both sides for the y term. And we can rewrite it. You could skip to the answer here if you're comfortable with that shortcut, knowing what the that b over 2 value to help you do the shortcut. I'm just going to rewrite this as x squared plus 10x plus 25 plus y squared plus 12y plus 36 equals 25 plus 36 is 61. And for the last step, we can just factor those. This is going to be x plus 5 squared plus y plus 6 squared equals 61. Okay, so for graphing this, for finding the center of the circle is going to be -5 comma -6, the opposite of what we see. The radius is going to be the square root of 61. So 61 is not a perfect square, so this doesn't end up being anything nice. So I'm just going to say it is approximately 7.8. So that'll help us graph it at least. Okay, so we go to the center, -5 comma -6. So that'll be down there. So it looks like our circle is going to go kind of off the edge here, which is fine, I guess. So a radius of 7.8. So we're going to go up 7.8. So it's going to be right up here. And we're going to go to the right 7.8. That'll put us right there. We go down 7.8. Just going to kind of eyeball it. And we go to the left 7.8. About there. And then we connect them. And it should look something like that. Okay, so for the last thing here, let's convert from standard form to general form. So we just went from general to standard, so now we're going the opposite way. So going from standard to general form, it's actually pretty easy. We don't have to complete the square or do anything crazy. All we have to do is expand out each binomial squared term and combine like terms. So we're going to essentially be distributing and then combine like terms, and that's it. And then get everything set on one side equal to 0. Okay, so write the following in general form. X minus 2 squared plus y plus 3 squared equals 5. So x minus 2 squared, I'm going to write this on the side. X minus 2 squared equals x minus 2 times x minus 2. If we were to FOIL that out, we should get x squared minus 4x plus 4. So that's going to be the first part. And for y plus 3 squared, that equals y plus 3 times y plus 3. We FOIL that out, we would get y squared plus 6y plus 9. So that's our second part. And we're going to combine like terms and get everything on the same side here. So combining like terms, we're also going to write it with the x squared term first, and then y squared term, and then the x term, and then the y term, and then the constant. So the only like terms that we actually have to combine are the constants. So it's going to be x squared plus y squared plus 4x plus 4y, or plus 6y, sorry. That was a, oops, sorry, that was a negative 4x right here. Okay, and then we have we have this 4 plus 9, which is 13, and then we have to subtract the 5 to that side, so we end up getting plus 8, so equals 0. Okay, so that is general form for that one. Next one, we have x minus 1 squared plus y squared equals 10. So let's just do the x minus 1 squared in our head. That one's going to end up being x squared minus 2x plus 1, and then plus that y squared equals 10. So let's get the terms in the correct order for general form. We have x squared plus y squared minus 2x. There's no y term here, so we have to subtract 10 on both sides and get 1 minus 10. So minus 9 equals 0. So that is our correct general form for that equation of the circle. Okay, so that is it for this section.